Welcome to this explainer. Today we're jumping right into what just might be the ultimate mathematical rule of reality, the first constraint, or as we'll be calling it today, C1. You can think of this as the absolute ground floor of existence. It's built on just one single, completely fascinating axiom. Nothing can fail to change. And together, we're going to unpack why this isn't just some high-level philosophical musing, but a hardcore structural mathematical necessity. It is literally the architecture that builds the universe from the ground up, ensuring that all things must inexorably and constantly change.
But right off the bat, we run into a massive, mind-bending paradox. I mean, if C1 dictates that absolutely everything must change, but the rule itself never changes, doesn't it just become a frozen fixed point? And if it's a frozen fixed point, doesn't it fundamentally break its own law? It's a really tricky dilemma. An unfalsifiable, unchanging rule of change seems to completely violate the very law it's supposed to enforce. So how on earth can a rule command universal change without exempting itself?
Well, to figure this out, let's start with our first section, the flawed outside audit. You see, our immediate instinct when trying to solve this paradox is to audit the rule from the outside. We want to just hit pause on the universe, freeze a frame of reality, pull the rule out, and systematically examine it. But that is exactly where the audit completely falls apart. An audit intrinsically assumes that you can step outside of a system and halt the flow of time to check things. But C1 completely forbids freezing. There are zero paused, frozen things in a reality governed by this rule. If you try to run an operation looking for a fixed point in a universe that mathematically outlaws them, your audit just returns null. It fails. You're actually breaking the rule just by trying to verify it from the outside.
We can't audit the universe from the outside because C1 is the vital precondition for us even existing to ask the question in the first place. The source material frames this perfectly, saying, I am inside it. Let me stop looking at the structure and start looking at the preconditions. Think about it for a second. Any observer, any auditor, any highly advanced measuring instrument you could possibly build is already in a state of change. You're being carried by the exact same current as the objects you're studying. C1 isn't a premise you check reality against. It's the very thing generating the reality you're trying to measure.
Which leads us perfectly into Section 2, fixed points versus invariants. Resolving this paradox really comes down to separating a fixed point from an invariant. Let's break that down. A fixed point is a place where the flow stops entirely. Imagine a massive heavy boulder sitting absolutely still in the middle of a rushing river, just resisting all that water. C1 completely forbids that boulder. An invariant, on the other hand, is what the flow actually conserves, like the total volume of water moving down that river. It doesn't sit still at all. It's a structural necessity preserved by the very act of moving. For there to be a fundamental law of change, something core must be preserved by the changing itself. To put some hard numbers to this, when we look at simulation data from a harmonic oscillator, we find this really intriguing value of exactly 1.0000. That represents the absolute minimum speed of any point in the system. The speed literally never drops below that threshold. What we're looking at is a mathematical proof that nothing ever actually stops. Zero fixed points exist. The motion is constant, perpetual, and totally baked right into the fabric of the simulation.
But at the exact same instant that the speed is locked at a minimum of 1.0, we get this incredibly tiny number, 0.000025. This represents the maximum drift of the invariant energy. It's essentially zero. So this shows us that perfect conservation is happening simultaneously with that constant motion. You're getting absolute mathematical conservation without any stasis whatsoever. C1 isn't a state sitting perfectly still. It is the conserved current of the flow itself.
All right, moving into Section 3, the add action proof.
This brings us to the actual mathematical proof of how a rule can change without destroying itself. The source uses this deeply thought-provoking phrase, it goes against itself to be itself. Now, that's not just poetry, okay? It's a rigorous definition. Under C1, the rule satisfies itself by being the exact wrong type of object to be a fixed point. It doesn't magically escape the rule by making some special exception for itself. No, it perfectly satisfies the rule by being a part of that continuous, unyielding flow. So then the question becomes, how exactly does a rule flow?
Well, it turns out it does this through a mathematical operation called an add action. You find this in complex structures known as Lie groups, which, if you're familiar, are basically mathematical ways to study continuous symmetry and smooth transformations, kind of like the continuous rotation of a sphere. Through an add action, the rule itself acts as the exact same species of thing as the state it governs. It isn't some external, unchanging dictator standing outside the crowd yelling commands. It's moving right there alongside the crowd. There is no external unchanging law dictating reality from a higher dimension. The universe is entirely self-referential, constantly updating its own rules as it moves forward.
And we can actually see this computational conservation right in the data. When running the simulation, every individual rule, the generator, changed by a value of 1.23. The rules physically moved and updated. But the law of how those rules combine, the bracket preservation, stayed perfectly conserved down to 1.3 times 10 to the negative 16th. Guys, that is computational zero. Everything changed, but the fundamental structure of change didn't, precisely because the change itself is an automorphism. It perfectly maps the structure to itself. Kind of like a Rubik's Cube, you can endlessly twist and change the colors on the faces, but the underlying mechanical structure of the cube itself remains perfectly intact.
So, bringing this all together, we hit section 4, the ultimate ground state. This finally reveals exactly why C1 is the absolute progenitor. It is the ultimate ground state. It's the path of least logic, the very thing that remains when absolutely everything that can change has changed. Endless change isn't complete amnesia or absolute chaos. Because think about it, if change were totally random, the universe would destroy its own computational capacity. The very fabric of time and continuity would just disintegrate. Instead, C1 acts as a continuous, stable computation that violently prevents the universe from halting into a dead end, all while conserving just enough underlying logic to remain a coherent universe. Again, it is the conserved current of the flow.
And it is just amazing to see the sheer scale of C1 across totally different fields of study. It's not just physics. In topology, the study of shapes, it expresses itself as the Poincare-Hopf theorem. You might know this as the hairy ball theorem, which proves that on certain shapes, like a sphere, a continuous flow of wind can never stop everywhere at once. There's always a cyclone somewhere. You literally can't comb it perfectly flat. In logic, it's Lauver's theorem. Both of these massive mathematical pillars rely on the exact same reality. A fixed point-free map exists. Because C1 demands absolutely no fixed points, logic dictates that no system can ever completely model itself. You can never perfectly predict a universe that is endlessly folding and updating.
So, I'll leave you with this kind of provocative thought. If the ground state of reality mathematically guarantees incompleteness, then your inability to know absolutely everything, to perfectly model your own future, or to completely freeze a perfect moment in time, well, that isn't actually a flaw in your thinking or your capabilities. It is the literal, mathematical proof that you are still alive, still unfolding, and deeply participating in the perpetual, wondrous change of the universe.